So last time we talked about graphing slopes and trying to get equations out of the graph and shortcuts for graphing linear equations from that slope-intercept form. Things like y equals negative 3/4 x plus 2. And if you graph that, of course, we start at the number that is not multiplying x. So in this case, that's the 2. We start at positive 2, 2 units up from the origin. And the number multiplying x is our slope. So that negative 3/4, we always put the negative with the rise. That's our numerator. So that means from our starting point, the positive 2, we go down 3 for a rise. Then our denominator was the run. We went over 4. And that gave us the second point on this line. Our line went through those 2 points. And then we did the opposite, where we had a line on the graph that might look like this. And we wrote the equation from that graph. We know y equals a slope times x plus a y-intercept. Remember, M was our abbreviation for slope and B our abbreviation for y-intercept. From the graph, we see the y-intercept here is positive 2 again. So B is positive 2. Our slope, then we have to find another coordinate or another lattice point on our graph. We have this one back here. We've drawn a triangle to connect them. We can see we've gone up 2, so that's a rise of 2, and over 1, 2, 3, 4, 5. So a run of 5. That's the slope of 2/5. So we have y equals 2/5 x plus 2 is the equation of that blue line. We also looked at what if we were given a line on the graph and had to find its slope from points other than axis crossings like we did up here, other than our x and y intercepts, if we just had generic points on the graph. So we might have a point like this. And our line goes through those points. This coordinate being 1, 5, and this coordinate here being 3, 2. Well, we can still do rise and run on the graph. We can draw in that little triangle. We can see this has gone down 1, 2, 3, so that's a -3 rise, and a run of 1, 2, so giving us a slope of -3/2. Well, we also looked at what if we didn't draw it on the graph? What if we just had those points, 1, 5, and 3, 2, and I wanted to find the slope? Well, we labeled them points 1 and 2, and our slope formula, M, which is slope, was y2 minus y1 over x2 minus x1. And remember, pulling the numbers out of our coordinates, y2 means we go to point 2, the y coordinate, which is the 2 in this case, minus y1, go to point 1, the y coordinate there is the 5. So that numerator is 2 minus 5, that'll give us the rise. Our run then is x2, so point 2, the x coordinate, being 3, minus x1, point 1, or x coordinate is 1. So 2 minus 5 is a -3, 3 minus 1 is 2, giving us -3/2. So that was our slope formula. Well, there is other information that we can find about these points from our graph. Let's talk about something called a midpoint. There we've got Prentice, welcome. We just kind of did a few minutes of reviewing what we did last class, and now we're just starting the new stuff right now. So midpoint, a midpoint is defined on any segment of a line segment, to be the point on that segment that cuts it into two equal pieces. Now, if this were a little bit more advanced class, we would talk about vectors and components. If this were a vector going in either direction, we'll just go left to right for now. Its components, we'd have a vertical and horizontal component would look like that. Those components basically would be the rise and the run of that line segment. The midpoint then of the whole segment is a combination of the midpoint of that vertical component, the rise, and the midpoint of that horizontal component, the run. So we need to be able to find the midpoint in each direction. So on my graph over here, if I have points let's say I have a point here at 2, 1, and its other endpoint is at 8, 5. That's connected as a line segment. To find the midpoint of that segment, I could look at those components. Again, the rise and the run, and deal with just the center point of that. Well, if I look at that rise as just being the change in y coordinates, the y coordinate here is 1, the y coordinate up here comes from that other point would be 5. So that comes from the second coordinate at each of those points. Well, the midpoint between 1 and 5, to find the number that's in the middle between two other numbers would just be averaging them together. 1 plus 5 over 2. Now, if you punch this in a calculator, make sure you hit equals after the 5 before you divide by 2. Otherwise, it'll give you something really kind of messed up. 1 plus 5 is 6, divided by 2 would be 3. So that's saying that would be at 3 here. The midpoint for our run, well, the x-coordinate for this point here is the 2. The x-coordinate for this point here is the 8. So the midpoint for the run would be between 2 and 8. Again, we just average them together. 2 plus 8 is 10, divided by 2 is 5. And then we list it out. The x-coordinate would be the 5. The y-coordinate would be the 3, part of the rise. So what that does for us is it gives us a formula. Given those points, x1, y1, and x2, y2, the midpoint, the point exactly between those 2 points, is the average of the x-coordinates and the average of the y-coordinates. Now note here, because we are adding, the order doesn't matter. x1 plus x2 or x2 plus x1 will give us the same result there. So if we have 2 points, we are asked to find the midpoint. Let's say I give you 5, -2, and -1, -12. To find the midpoint, we'll label these points A and B as their endpoints. So the midpoint we're looking for is point M. To find that midpoint, the x-coordinate of the midpoint is the average of our x-coordinates of our endpoints. So we have 5 and -1. So 5 plus -1 is 4, divided by 2 would be 2, is our x-coordinate of our midpoint. Our y-coordinate then is found by averaging the two y-coordinates. -2 and -12. So -2 plus -12 over 2. -2 plus -12 is a -14. Divided by 2 is -7. Gives us 2, -7 as our midpoint. We'll do one more example there. Let's do a -8, 1, and 2, 9. Find the midpoint of that. So if those endpoints A and B, our midpoint will become the x-coordinate. Again, we use the x-coordinates out of the two endpoints. So we've got -8 and 2, so -8 plus 2 over 2. -8 plus 2 is 6, divided by 2 is 3. For the y-coordinate, we use the 1 and the 9, the y-coordinates from our endpoints. So 1 plus 9 over 2. 1 plus 9 is 10, divided by 2 is 5. So we get that midpoint of 3, 5. Well, this formula is relatively straightforward and easy to use. Where it gets more difficult is if we're asked to go in the other direction. Instead of being given both endpoints and being asked to find the midpoint, let's say we were given that the first endpoint is 2, 7. But instead of being given the other endpoint, we're given that the midpoint is at 5, -1. How do we find that other endpoint? Well, here's what I'm going to do. I'm going to just call that other endpoint xy for now as its coordinates. So given these 2 points, these 2 endpoints, point A being 2, 7, and point B being simply xy, we would find the midpoint by averaging the 2 x-coordinates, 2 and x, so 2 plus x divided by 2 would give us the x-coordinate of the endpoint. Well, we have that coordinate. It is 5. So that gives us an equation that we can solve to find that x-coordinate. So to solve this for x, well, looking at it, what's happened to x is 2 was added to it, then the whole works was divided by 2. So to solve it, we start out by multiplying by 2. So 2 plus x equals 5 times 2 is 10. Then we'll subtract the 2. So subtracting 2 gives us that x equals 8. So the x-coordinate of that second endpoint is 8. Now we do the same thing for the y-coordinate. To find the midpoint, we would have taken the 2 y-coordinates of the endpoints. That would have been 7 plus y. Divided by 2 would give us the coordinate of the midpoint. Well, we know the y-coordinate of the midpoint is -1. So we'll put that in there and we will solve. First thing we have to do again is multiply by 2. So that eliminates the 2 there. We have 7 plus y equals, here we have -1 times 2, which is -2. And then we get y by itself. We have to subtract the 7. So the 7's gone. Y equals -2 minus 7 is -9. So the y-coordinate of that other endpoint was -9. So point B, the other endpoint, is 8, -9. Let's do one more of those. So let's say this time I'm not going to give you point A. I'll tell you that point B is -3, 12. And our midpoint is going to be 1, Let's do 1, 5. Let's find point A. Now again, I'm going to label point A as just xy for now. So then if from points A and B, if I were trying to find my midpoint, I would add the x coordinates. That would be x plus -3 divided by 2. And we know that's going to give us 1 is our coordinate of our midpoint. So we will solve by multiplying by 2. So x plus a -3 equals 1 times 2 is 2. And that's a -3. We can either subtract a -3 or add a +3. Works the same. So x equals 5. For the y coordinate, we'll do the same thing. So we've got y and 12. So y plus 12 divided by 2 has to give us 5. So we start out, we get rid of the 2, so we multiply by 2. Y plus 12 equals 5 times 2 is 10. To get y by itself, we subtract the 12. Y equals 10 minus 12 is a -2. So that other endpoint is 5, comma, -2. Well, another thing that is handy to be able to find is the distance between 2 points. Or if you think of it as being a line segment, the length of that line segment. So let's come over here again and plot some points. Let's say I have a line that has one point here at 2, 6, segment I should say, and the other point is down here at 14, 1. Of course, they're connected by a line segment. Well, for our midpoint, we looked at that vertical and horizontal component, which just turned out to be our rise and run. Well, we can do the same thing here. This rise is going down 1, 2, 3, 4, 5. The -5 rise. Our run here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's a run of 12. Well, because vertical and horizontal always form a right angle, that is a right triangle. If you recall from your basic geometry, to find the hypotenuse of a right triangle, you would normally label the hypotenuse side C. The 2 legs make the right angle. The 2 shorter sides are labeled A and B. You have A squared plus B squared equals C squared. C is going to be the length of that segment, or the distance between those 2 points. So I'm going to solve that by square rooting. So instead of having it as A squared plus B squared equals C squared, C is equal to the square root of A squared plus B squared. Now going back to our formulas, if I have point x1, y1, and point x2, y2, A is just the rise. So our distance, or our length, is equal to A. Well, A, our rise, remember A is, I'm going to put B first, the run first, just because that's the way I'm used to seeing the formula. So let's do the run first. The run was expressed in our slope formula as x2 minus x1. That's got to be squared. Plus our rise was represented as y2 minus y1. And of course, that length has to be squared. So from those points, I can find the length of that line. I had the point 2, 6 and 14, 1. I'm going to call the 2, 6.1, 14, 1.2. X2 would be 0.2, the x coordinate is 14, minus x1, 0.1, the x coordinate is 2. That's going to be squared. Plus y2. Well, 0.2, the y coordinate is 1, minus y1. 0.1, the y coordinate is 6. So that's going to be 1 minus 6, and that's going to be squared. So as we work through it, 14 minus 2 is 12. That's going to be squared. 1 minus 6 is a negative 5. That'll also be squared. Note that on your calculators, you do have to leave that negative in parentheses to square it. Twelve squared is 144. Negative 5 squared is 25. Add those together, 144 and 25 make 169. The square root of 169 is 13. So the distance between those 2 points, or the length of that segment, is 13 units. So let's take a look at some examples here using that formula. So let's say that we have 2 and 8 is one endpoint. And let's do negative 4 and 16 as the other endpoint. Find the distance between those 2 points. I'll call this point 1 and point 2. That distance, or that length of the segment, however you want to look at it, is going to be the square root of x2, 0.2 x coordinate is negative 4, minus x1 is going to be the 2. That difference is going to be squared, plus we have y2, 0.2, the y coordinate is 16, minus y1, 0.1, the y coordinate is 8. And that, of course, that's going to be squared. Now, at this point, you could just punch this all in your calculator. Square root of parentheses, negative 4 minus 2, close your parentheses, squared, plus parentheses, 16 minus 8, close your parentheses, and squared. And it does give you that that is 10. So the distance between those 2 points is 10 units. Now be careful, and many of you, if you're using the graphing calculator, most of your TI-84s will do it exactly like I did here. Some of your TI-83s, rather than giving you the whole thing underneath the square root symbol like that, would just give you the square root symbol with the open parentheses. And most of your scientific calculators that are not graphing would do the same thing. So when you do that, you still have to put in that first parentheses. So you have 2 right after the square root symbol, negative 4 minus 2, close parentheses, squared, plus, in parentheses, the 16 minus 8, close parentheses, squared. And you would have to remember to close the parentheses at the end of the square root then. Tell the calculator that that is all, from this parentheses to that parentheses, is all part of the square root. Now we can do something similar here to what we did with our midpoint formula. I might tell you that we have a point negative 3, 7, and we have another point that has an x coordinate of 5 and has a negative y coordinate, and I tell you that the distance between these is 17 units. So let's take a look at this. Now our distance is 17. That's going to equal the square root of, I'm going to call this missing coordinate here y. Negative, or x2 is, x coordinate point 2 is going to be 5. Minus x1 will be the negative 3. So we got to be careful. This is minus a negative 3. Got to make sure both negatives are in there. Some might put parentheses around that negative 3 to keep it straight. Plus, now y2 is going to be just the y, minus y1 will be the 7. That's going to be squared. So now, inside of parentheses, 5 plus a negative 3 is 8. 8 squared is 64. Over here, y minus 7 squared, you'd have to do out y minus 7 times y minus 7. It would be y squared minus 14y plus 49. And you would have to solve from there. We get rid of the square root symbol by squaring it. Squaring and square root would cancel each other out. 17 squared is 289. Over here, all we would have is what's left inside of that. I'm going to combine the 64 and the 49, which is going to give me 113. So I got y squared minus 14y plus 113. And now we have to solve this for y. Subtract 289. Get 0 equals y squared minus 14y minus, what was that, 176. This is a quadratic equation. It means it's going to have two answers. In this case, it's going to have one positive answer and one negative answer. That's why up here I had to specify that y was negative, that y coordinate is negative. Solving this quadratic is a problem we'll come back to next week. We'll look at factoring those quadratics, factoring those equations. We'll actually be looking at some shortcuts for graphing them, just like we did some shortcuts for graphing lines. So now also earlier this week, we saw that if we were given a slope of 1/2 and a y-intercept of 3, that we could very quickly construct the equation. Y equals the slope, 1/2 times x, plus or minus the y-intercept. Y-intercept here is positive 3, so it's plus 3. We even picked that information out of the graph and used it to write the equation. Now, what if we, instead of having the y-intercept, we just had a point that was on the line? Slope, let's say the slope equals negative 3/4, and we're given that it goes through the point, well, let's say it goes through the point 8, 1. Now, we did see that we had point slope form of a line. I could write this equation very quickly in point slope form. Remember, point slope form was y minus y1, which is our coordinate, equals the slope times x minus x1, which is the x coordinate of our point. So y minus, our y coordinate here is, it's not the 8, it is the 1. So y minus 1 equals slope, negative 3/4 times x minus, our x coordinate is the 8. And that is an equation for that line. We have another way we could go about it. We could say, hey, y equals slope times x, that'll be negative 3/4 times x, plus a y-intercept. That y-intercept is represented by the letter b. We did this actually a little bit on Wednesday as well. If I want to know what b is, I know that this point, 8, 1, makes that equation true. So I can put 1 in for y and 8 in for x, and I can solve to see what letter b has to be. So I'm going to combine. Negative 3/4 times 8 is a negative 6. So 1 equals negative 6 plus b. It's a negative 6. I'm going to add 6. 1 plus 6 is 7 equals, the 6's cancel out, and I just have b. So 7 equals b, which is telling me that up here, that y-intercept is 7. So instead of y equals negative 3/4 x plus b, I get y equals negative 3/4 x plus 7. A little bit of work could show you that these are equal, by the way. Distributing the negative 3/4 here, negative 3/4 times x is negative 3/4 x. Negative 3/4 times negative 8 is a positive 6. Add 1 to both sides to get y by itself. And you see that y does equal negative 3/4 x plus 7. Our next possibility would be, instead of being given a slope and a single point, what if we're just given 2 points? What if we're given the point 6, 7 is on the line, and the point 3, 8 is on the line? Well, I'm going to argue this is the same as what we just did, because when we're given 2 points, we can find the slope. Our slope, I call this point 1 and point 2, is going to be y2 minus y1, so 8 minus 7, over x2 minus x1, so 3 minus 6. 8 minus 7 is 1. 3 minus 6 is a negative 3. So it gives us a negative 1/3 as our slope. I have actually 3 options here. The first 2 options would be involving that point slope form. I could use point 1 and that slope, say y minus 6 equals negative 1/3 times x minus, shouldn't be y minus 6, it should be y minus 7 is the y coordinate. Y minus 7 equals negative 1/3 times x minus 6. Or I could use the second point and the point slope, y minus, the y coordinate is 8, equals negative 1/3 times x minus 3. Those 2 equations, even though they look very different right now, are actually equivalent. The third option is to use slope-intercept. Y equals our slope, which is negative 1/3, times x plus b, the y-intercept. We can pick either of those points to put in, so it doesn't matter which. Let's take the first one. So 7 goes in for y, and 6 will go in for x. So I have negative 1/3 times 6 is a negative 2. Adding 2 tells us that 9 equals b. So this up here, we replace b with 9. So that'll become y equals negative 1/3 x plus 9. If you double checked, you would find that both of those equations are equivalent to that. So let's do one more example of that. So find the equation. I'm going to specify in slope-intercept form. Slope-intercept form, by the way, is sometimes called graphing form. Because remember, that is the form we needed it in to graph it if we're going to do it quickly. So find the equation in slope-intercept form for the line going through the points. 2, -7, and 6. Oh, let's see here. 6, 1. So our first step, no matter what type of equation we're making out of this, is going to be to find the slope. So the slope here, y2 minus y1, well, let's label this 1 and 2. y2 is going to be the 1, minus y1 will be the -7, over x2 minus x1. Well, x2 is 6, minus x1, which is 2. 1 minus a -7 becomes 1 plus a +7, which is 8. 6 minus 2 is 4. 8 over 4 reduces to 2. That has a slope of 2. So to write our equation, y equals 2x plus whatever our y-intercept is. Again, we can pick either point. Let's do the second one this time, just to change it up. I'm going to put 1 in for y. 6 goes in for x. 2 times 6 is 12. So 1 equals 12 plus b. And I'll subtract 12. -11 equals b. So back up to this equation here, b becomes -11. So y equals 2x. Instead of plus b, since it's -11, we just put in -11. Okay, that brings us to the end of our time for the day. If you look in Blackboard, there are 2 worksheets. You go to course information. I get to the right Blackboard class here. Don't know where spring went. Oh, I know where it went. Anyway, you go to your website for Blackboard and you go to course information. There we go. All the way down at the bottom of the page, there are 2 worksheets. Finding the equations from the points and the slopes, and then that worksheet on slope, midpoint, and distance formulas. So that'll be your homework over the weekend. You guys have a great weekend, and we'll see you on Monday.